Hello dear students, today we will learn the deflection in frame by unit load method. Now for that we have taken this example. This is a frame is subjected to load 50 kN and this distance 2 meter and this horizontal is a 6 meter. These columns are having the I and this beam is the 2I. For that our aim is to find the horizontal displacement at the support D. So at the support D, we have to determine the displacement. For the unit load method, we have to draw the same frame and apply the unit force where we desire the displacement. So in this case, we require the horizontal displacement. So you have to draw on the same frame and apply the unit force at the D where we desire the displacement. Now first step is to calculate the reactions. So here is a reactions. So we will take sigma MA is equal to 0. So this is a clockwise movement is a 50 into 2 and here this is a vertical reaction here. This is anti-clockwise, that is with minus 6 RB is equal to RD is equal to 0. So this RD becomes the 100 by 6 kilonewton, or you can say that is a 50 by 3 kilonewton. So now here this answer is positive. It means what we have assumed direction vertical. This is the correct. Now here there is no vertical load, that is why if you apply the sigma Fy condition, so this becomes the downward here, and the same, that is the 50 by the 3 and this is 50 by 3. Now here is in support, so the horizontal load. So here reaction is what? If you apply here sigma Fx, so here is toward the right. If you consider this is a plus and this is minus, so suppose we go on the here HA. So suppose we assume the direction of HA is like this. So that is the 50 is a plus and this HA is a minus, so is equal to 0. So HA is equal to 50 kilonewton. So this becomes the 50 kilonewton. Again same way you have to find out the reactions at here. There is no vertical load, so the vertical reactions are 0. Now here is a horizontal force 1. So here is a reaction 1. Okay. Then we have to prepare one table, that is the origin, section, then the moment of inertia I, then limit, then capital M and then the small m. Now capital M is the bending moment due to the external loads and small m is the bending moment due to the unit force. So now divide this frame into different section. Now we divide this first. This CD is a one section our. Then this BC is our one section. Then this, suppose this we give this name as E here. So this is B is one section and here AE is our one section. Okay. So now to write the sections, write the limit and then calculate the bending moment. Now starting we are from the D here. So we are considering origin as our D. Okay. Section is CD. Here I is equal to I and here we are taking the limit is 0 to 4 because this distance is a 4 meter. So 0 to 4. Now here the bending moment. Now we know here this is our frame and here is a vertical reaction 50 by 3 and this is our section XX. So what is here? This is our resistance is X. So this force is axial force. This is why it doesn't produce any type of the bending moment. So that is the 0. So here bending moment is the 0. Now same section is here. Okay, same section is here. And same section is here. Now for the first case that we know, this is now the, for here, if you consider here, now this is the force. Okay, this is our X. So what is here? If you rotate this and make it like this, so what is here? This is one force. So 1 into the X, and this create the what? It's like, so this is the sagging bending moment. So here the moment is 1 into the X. Okay, now go for the second section. Suppose now we are taking the origin as a C here. Span is B to C. Here I is equal to 2I. Okay, and limit is, we are taking origin C, so limit is 0 to 6. Now importance what is the M. Now here if you draw a free body diagram here, now this is the force is 50 by EI. So this will act here one force, that is 50 by 3. This is a vertical downward, so here should be the vertically upward force 50 by 3, and we know this is our distance is the X. So 50 by 3 into the X. Now this will try to push this upward like this. So again this create the sagging bending moment. So this moment is 50 by 3 into the X. Okay. Now for second section, so for the bending moment in BC span, in the same way, here is what? Free body diagram. Now here is what? This is the force is 1. We know the distance is 4 meter. So this joint is a rigid joint at here. This joint is a rigid joint. So this is anti-clockwise. So here moment produces the clockwise. Well, how much that is? 1 into 4. So that is 4 kilonewton meter. So this is the clockwise. So here produce the anti-clockwise. How much that is? 4 kilonewton meter. Because we know at any joint we know that sigma, the joint is C, so sigma MC is the 0 to satisfy the static equilibrium condition. So now this moment is acting on this beam like this. So this creates what? And this is our X. So moment doesn't have any distance. So what is here? This create the what? Like this. So that is why is a sagging and only the 4. So here this is the 4. Now we are taking these two sections. So now first we take this section. Suppose this is our third section and this is our fourth section. Now for this section we are taking the origin is our A. Now the span is what? Between this A to E, because the section is in between the forces. So this is one section, is another section. So this is A to E. Here EI is equal to this I. Then limit is what? This is 0. This is 2 meter. So 0 to 2. Now the bending moment here. So now we look here the bending moment. Now we know this is a force, is 50 is acting. This is a vertical force downward is 50 by 3. This is a force is 50 and this is our x. So this force becomes the axial force. So this does not produce any type of bending moment. So only this produces the bending moment. So again, if you make it like this, so this is for how much bending moment is 50 into x, and this try to push this upward like this. So again that bending moment is the positive. So that is how much is 50 into the x. 50 into the x. Now same case for this here, the bending moment that we know. Here is a force, so here is a one force, 1 kilonewton, one force unit for not kilonewton, 1. This is our load 50 and this is our section x, and this is the force is 1. So how much bending moment is 1 into the x. Again this try to push the shape in the sagging direction like this. So that is why is positive 1 into the x. Then the last section. Now we are taking the same origin over a. We are not changing the origin a. But span is what? This BE. For that I is equal to I. But already 0 to 2 is completed. From here to here 2 is completed. So limit is what? 2 to 4. 2 to 4. So now this is our x for this section. Now we should draw separately here like this. This force is our 50. Okay, 50 by 3. Now this is the 50 and anywhere is our section. Now this is our x. Okay, so what here? This 50 produces the what? Is the sagging bending moment. How much is 50 into distance is x. So right here 50 into the x. We know the distance is 2 meter and this is, so now this produces what? Now if this is sagging, so this produces the hogging, so that is the minus here. Okay, then we want this distance. So how much is it? This is x, this is 2, so this becomes x minus 2. So 50 into x minus 2. So here becomes 50 into x minus 2. And now for this unit force, again this is our force is 1 and this anywhere is x. Same is here. So this is again produces the sagging bending moment 1 into the x. Now if you take here, this is our now x. So what is here? 1 into the x. So this becomes 1 into the x. Okay. Now we write the, now this 0 into 1 into x means that becomes 0. So 1, 2, 3 spans. So we here write the equation. So that this delta d is equal to integration here. First is now here 0 to 6 50 by 3 into x into 4 dx divided by 2ei plus then 0 to 2 here is what? 50 into x into x. So 50 into x into x into dx divided by here I is I, so here is a plain EI, and the third one here integration is 2 to 4. Okay, value is what? 50x minus 50 into x minus 2. So 50x minus 50 into x minus 2 into the x. So this total multiplied by x dx upon the EI, because here I is equal to I. But this formula is what? Anywhere delta by unit force method is integration is capital M into small m into dx by EI. By using this formula we have to put all these value. So if you calculate this delta D, so this becomes 4000 divided by 3. Okay, so have you understood? So okay, this is a way is to find how the displacement in the frame at the joint. This method is applicable for the determinant structure.